Hello, let's continue our Sudoku adventure with Frost and Fire by Matt Tressel. So this continues our arrow theme week. I hope you're enjoying it. This is an interesting one. We have thermal arrows. So let's go over what these mean. So we do have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. So this is the simplest one on the grid. So I'm going to talk about this one, or maybe this. Anyway, let's talk about this one. So there's an arrow and there's a circle attached to the arrow. The digits on an arrow sum to the value in the circle. So if this was 2, 3, that adds to 5. That puts a 5 in the circle. Or alternatively, if we place a 5 in the circle, these need to add to 5 in some way. So they agree with each other, basically. Now, we can have multiple arrows sharing the same circle. That does not mean that you take like all of these adding to the circle. Like that wouldn't even work, right? They're independently adding to the circle. So whatever this circle is, if this was 5, we could do like 2, 3, 1, 4, 2, 3, right? And this adds to 5, this adds to 5, this adds to 5, and this is a 5. So that would be a valid way to fill that. Other than the thermal part. The thermal part is interesting. So these top two are blue and these bottom two are orange, just in case you have trouble distinguishing those two colors. I know it's rare, but just in case. So the blue ones that are on top strictly decrease from the arrow towards, but not including the circle. Obviously, it can't include the circle, but that means that this digit is the biggest digit. So this could be, say, a 3, and then this has to get smaller. It doesn't have to be a 2, it just has to be smaller than 1. And then the circle is just their sum, right? So we're decreasing from the arrowhead. The orange are opposite. They increase from the arrowhead. So we could go 2, 3, and that would add to 5. Or we could go 2, 4, and that would add to 6. They increase from the arrowhead. All right. Blue decreases from arrowhead. So think about it as like a thermometer, but the circle of the thermometer is the arrowhead, not the circle of the arrow. Anyway, those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. The first thing that I saw was actually in my example, this and this. We need 2 ways with 4 distinct digits to add to this circle. So the 4 distinct digits, that means we're going to add to 5 or 6, because 4 you can only do 1 plus 3. We can't repeat any digits in this column. We can't do 2 plus 2, not because the arrow would restrict it, but because Sudoku does, the column. So we could do 5 or 6. 4 is too small, because 4 would be 1, 3, and 1, 3. Now, if we added to... So this digit here doesn't go on its own arrow, right? So the 5, 6 goes up here somewhere, and joining the 5, 6 is either going to be a 6 or a 3. If this is a 5, notice you can't put a 6 on these. That's way too big. So you'd end up with a 5, 6 pair up here. If this is a 6, you actually can't do 3 plus 3. So 3 is going to be the odd man out, and 3 will end up there. So this is 3, 5, 6, and always has the 6. I don't know that we can immediately say, well, this has to be high. We have to be careful about this arrow, though. These are 4 distinct digits. So one little trick we can do here, which I don't know if is helpful, but it's sometimes helpful in arrow puzzles in general. So we'll talk about it, which is we can think about the minimum that these 4 digits sum to. And that would be 1, 2, 3, 4, leaving the 5, 6 over here. And that would work. So we could put 1, 2, 3, 4 here. Now, if we did that, then that means that it sums to at least 10, meaning that these two circles also have to add to at least 10. Because the sum of these 2 is here, and the sum of these 2 is here, so the sum of these 4 is the sum of these 2. Hopefully that makes sense. It's just math, right? Algebra. So these 2 need to add to 10 or more. So this cannot be a 3, because that would mean this would have to be a 7 or higher. So this actually is not a 3. Don't know what else I can do though. Oh, well, I mean, this has a minimum value of 4. So this is 4, 5, 6. Because if it was, again, 3 doesn't work. This would have to be 7 or higher. Okay. But it's not a 4. We know it's 5, 6. We already knew that. So that was kind of pointless because we have the exact same logic here. So that exact same logic here does put 3, 5, 6 here. Definitely one of these is 6. And can this be 3? I think we are less restricted here. This could potentially be a 3 with a 1, 2 here. Okay. So now that we've done that, I want to think about the actual thermo part of this. So the orange circles, the orange arrows increase from the arrowhead. So if we are adding to 5, we're either going to be doing 1, 4, or 2, 3 in that order. And if we're adding to 6, then we're either doing 1, 5, or 2, 4 in that order. So there's always a 1 or a 2 in this cell. Same thing here. 1 or 2 with a 3, 4, 5. And then that's going to be true here as well. 1 or 2 with the 3, 4, 5. And that's going to be true here as well. So these are all, but these are backwards. So this has the smaller, it gets smaller as we move away from the arrowhead. So these are the 1, 2s, and these are the 3, 4, 5s. Okay. So what does that get me? I already kind of baked in the 1, 2 pairs when I penciled these guys. This is 5 or 6 as well. So this is going to be 1, 2 with a 3, 4, 5. Yeah, there's our 1, 2 pair again. I wonder if we should color the 1, 2 pairs. That might be helpful. So we'll just use green, purple, my kind of defaults to start out. So that's green, that's purple. What if you have not seen the coloring technique before? All I'm doing is I'm symbolically calling this green and purple. So whatever, if this cell in the solution ends up being a 1, then green is also 1. And that would make purple 2, because we know purple is not green. They share a row. Otherwise, the only other world is that green ends up 2, in which case purple is 1. So we don't know which is which, but we know that they're opposites. So what this tells us is that every cell that's purple is the same digit as each other. We don't know if it's 1 or 2, but it's the same. And whatever is green is the other one. So this is our green. And this can help us like determine interesting things. For example, this green looks in here, this green looks in here, and this green looks in here. So where is green in this box? And the answer is it can only be right here, which is a 1, 2. And we do have to increase from here, so that's not too surprising. But where's purple in this box? This purple looks in, this purple looks down, and this isn't a 1 or a 2 because of the thermo aspect. And so purple ends up here as a 1, 2. 1 plus 2 is 3. That makes this 3, that's 6. With 3 missing, this has to be a 6. And this is a 4, 5 pair. This is not a 3, but that does not tell me the sum yet. Let's see, what else can we do here? So this is the other 4, 5. We can color 4, 5s. I don't know how fruitful that is at the moment. The problem is I can't relate these 4, 5s to these 4, 5s at the moment. At least I don't see a way to do it. We do have these 2 6s looking up, so 6 ends up over here. See, what else can I do here? We know where almost all okay, we know where the final green is. This is green, 1, 2. We have all our greens. What about purples? We have 4 purples. Right, we can place this purple here. And we should be able to place this purple here. Okay, so we have all the green purples. We just don't know which one's 1, which one's 2. Oh, this 6 looking in here tells us this has to be 6 because these 2 can't be. So that's our 6. And so now we know they add to 6, meaning these can't be 3s. And so we end up with this being the 3, and this has to be the 6. These add to 6 with a 4 or 5 there. Okay. So what I can actually do, this might be interesting, is I can actually continue to use, I won't continue to use green, but we'll remember an association. So green is associated with blue. Those both feel like cool colors, I guess. Purple I'll associate with orange. So green and blue go together, and orange and purple and orange go together. Why do they go together? Because that's how you add to 6. So green plus blue adds to 6. You can see that, and orange plus purple add to 6. So one of them's 1, 5, one of them's 2, 4. We don't know which, but we know that they kind of go together. And so now that does allow us to relate these colors to these colors, because we know green goes with blue. We know purple goes with orange because we're adding to 6. Makes that one blue. And that places blue in here. This is the blue 4, 5. This is now the orange 4, 5. We know that a couple ways, reasons. We can place the 3 up here. This is the orange 4, 5. 3 in the corner is deep dooting. This can't be blue or orange, so this is 3. See, it's a blue and an orange. So this is blue for the column. And then this is a 3. And this is a 6. And this is our orange 4, 5. Okay. So now we have to distinguish these. Let's see, this is a 3. How do we distinguish the ways to add to 6? So circle I'm ignoring, or interesting. What would violate here? Oh, it's the sorry. I could have distinguished this a long time ago, but it was actually kind of fun to keep the colors. Yeah, this is the thermal arrow. This is what does it. Okay, sorry about that. All right, so which way does it go? Orange increases towards the circle. So this is the lower digit on orange. Yeah, and that's how I've been doing it. So that means all the greens are 1. It means all the purples are 2. And then that means all the blues, to add to 6, are 5. And all the oranges are 4. All right, that was pretty funny, but I think it was worthwhile to actually have finished all of the pairs and coloring all the pairs before we before I realized, wait, I could have distinguished that a while ago. So that's fun. All right, cool. And this coloring trick will help you in the future. The different techniques I use, just even being exposed to it once, can often very much help you in future puzzles. And 9x9s, where you're doing a whole lot of coloring, it often doesn't disambiguate right away. So can really help you get through the puzzle. Cool. Well, I enjoyed that quite a bit. Thanks, Matt. This was a neat puzzle. And I hope you also enjoyed it. If you did, then why not leave a like, subscribe, and a kind comment below.